Okay. Yeah. Today we're going to study the area of the triangles. Well, that's easy, right? Area of triangles. Well, first of all, recall the definition of the area of a rectangle. In mathematics, we have to begin with the definition, right? Definition for a rectangle, right? If this side is A, this side B, the area is defined to be the product of those two numbers. Okay? It has a geometry, meaning why is product, because that's where how do we, if we divide it, if it consists of many squares, that means just area means the number of the unit squares. Okay, that's why this multiplication here, 1, 2, 3, 4, 6, right? So that's why area tells you how many square here. This side 2, this side 3, right? And area is given 2 times 3, that's a 6, so that's 6 squared then. 2 rows, 3 columns. Okay. Of course, A is not necessary to be integer, B can be any number. Okay. Now, that's a definition, okay? But how to find the area of the triangle? Well, different people come up with different formula. Well, the natural idea is to use H and the base, the B, okay? And then the area is going to be, we were told that B times H. Now, why is B times H divided by 2? Okay, so you can prove, this is a formula, okay? This is a formula, it's not a definition, okay? If you use a definition, you have to prove that this does not, this is this is well defined, right? So anyway, so how do you see why this is true? Well, the idea is you duplicate this, okay, double it, and then you cut this piece and put it here. So the double of the triangle as this piece, okay, is moved here. So you get a rectangle, right? Two triangles glued together, you cut this one corner and then move it to here, and then you get a rectangle. Now the rectangle, the width is h, the length is b. So the area of the triangle is going to be half of the area of this rectangle, right? Half of the area of the rectangle. Rectangle is going to be h times b for the area. So that's why, how do you get this? And that's the first formula, right? The second formula, some guy says, well, if you have a triangle, right? If you have a B and A and C, so this become a triangle. It is a triangle. Those three numbers are the length of the triangle. If you only have a satisfying following three encoded, we call it triangle encoded. Okay, A, B, C are the as a lenses of three sides of a triangle. Okay, if and only if A plus B is greater than C, B plus C is greater than A, C plus A is greater than B. Okay, those are called triangle encoded. If one of them is not satisfied, then those three numbers cannot be the edge length of the triangle. Okay, and look at that, right? Look at that. Okay, so the distance from this, between, this is A, that's a B and C. The distance between A and C is B, right? And this should be shorter than the distance between C and B and A. So if you go from C to A, you have, is the shortest path will be the strict length, or a strict line. If you go to B first, then to A, then it's much longer. That's why B should be less than A plus C. Okay, this is called a triangle. Now, given A and B and C, if they are satisfying those three inequalities, then there's a unique triangle such that the edge lengths are A, B, C, respectively. So you can, okay, we can we express the area in terms A and B and C, right? Right? Instead of B times H, you still have height, right? What is the height, right? The height is not given. You only given A and B and C. So there was a person called Huron, and he proved that the area is going to be square root S, S minus A, S minus B, S minus C, and S is going to be half of the parameter. Okay. Why this is true? Yeah, why this is true? Now, I hope, okay, don't look at book. I hope you can prove it. Okay, if you can prove it, let me know. Okay, so let's check his formula. Check Huron's formula for a right triangle. Okay, let's make sure this is, if it's a right triangle is true, then this maybe it's true, right? For a right triangle. Okay, let's say, so this is a B and A and the C, okay? So for in a right triangle, for a right triangle, the area is going to be A times B divided by 2. We know that. But how can I get this right from above formula? Right? From above formula. So why this is true, right? S minus A, S minus B, S minus C. It's hard to tell. Right? Why this is true, right? Can you see that? Well, probably not, right? So A plus B plus C is S is half of that. It's very good. So let's take a look at the specific one. The specific one is here's a 13, here's 12, here's a 5, right? Right? 5 square plus 12 square equals 13 square. Okay. Right, so the area is going to be half of 5 times 12. And I think it's 30, right? We're using this formula. Now, let's let S to be the half of this, okay, the perimeter, okay? So 5 plus 13 is 18. 18 plus 12 is going to be 30. So divided by 2 is 15. So 15. So the square root of 15 minus 5, 15 minus 12, 15 minus 13. Let's see if we can get 30. Okay. So 15, 10, 3, 2. Okay. So 15 is a 3 times 5, 10 is 2 times 5, then 3 and the 2. How many 2's there? That's 1, 2 squares, 3 squares, the 5 squares. So I got 30 again. So it's just the same. So therefore, you verify the above formula. It's correct, right? But that's not proof, in mathematics. This is not proof. This just verify the formula is true, more likely it's true, okay? Because I use this specific example. Check that. Okay, it is not by luck. No, this is this just from the competition. You can I think from competition you can see this formula is true. Okay, so so more likely this formula is true for the general triangle. Okay. So I want to look at the next problem. I draw something like that. Okay, here's a AB, and this side is this side 3, is this side is 5. ABC, ABC, this is a rectangle. I pick up 3 points on on the two sides, and then connect the line. So my question is, are we able to determine the total area of the shared region? So it consists of two triangles. Is the area independent of location C and A and B and C? Okay, question. Is the area of the shared region, okay, independent of the location, the locations A and B and C? Okay, when you move the point A, B, and C, okay, do you change it? You change the shape of the region, right? Of the yellow shared region, but do you change the area too? Okay, so think about it. If it's not, prove it, right? I let you to think about, and if it says as independent, so then what is the area of the shared region? And maybe, you know, you can say cannot be determined. Right, anyone has answers? Yes or no? Can you completely determine the shared, the area of the shared region? The shared region consists of three triangles, but what do you know is the height of the triangle, each height, right? So the both are equal to 3, right? But you don't know the base. So let's call it A, that's a B. The total area is going to be half of the area of the first triangle, base times height, and B times height, right? So you see there's common fact, take it out. Okay, that's going to be 3 over 2. Then A plus B. Now A, B are not determined, right? A, B are not determined, each individually, right? Because I can move the point C left to right. But the sum of these two numbers is fixed, which is 5. So that's why it's going to be 15 over 2. So yes, it is independent of location of A, location of C, but it's independent of location A and B is obvious, okay? Because it only depends on the height. The height is the same, okay? So we solve the problem. Right, about, okay. Yeah. So here's another problem. This is a square. Okay, unit, I call it unit to square, that's fine. Okay, so I have A, B, C, and D, it's unit square. So what I'm going to do is I choose the point M, that's the middle point. And I choose a point P, this is another middle point. This is choose point M, that's middle point. It's not, okay? So D, P, and the PC is going to be 1 over 2, okay? And this is also equal to B, and that point is called N. Bn and Nc, okay? M is the middle point, so M equals Nb. Okay, so this is a condition. So find the area of the triangle P and M. Right, so please work on that. So the triangle is uniquely determined at this time, right? So it should have an area. So what is the area? We only have two formulas, right? Either of them can be used here to solve the problem quickly. Okay, anyone has answers? Ethan, Chi, Krista, Calvin, Kenneth, Lala, Lydia, Michael, Ovi. So, Lala, can you figure it out? Is this your first name or your mother's name? I'm just confused. Some people use a mother's name, right? Okay, good. Yeah, you are taking both courses. Geometry is pretty challenging, okay? Yeah, so when you see the triangle, right, you want to find the area. So you only have two formulas. One formula is to use the area, the base times the height. So when nothing is given, then you have the formula using three sides of the triangle, but they're not given. So you have to find out them. But do you really need to do that? Because the Huron's formula usually involves, it's a radical, right? So, and it takes too much time to find out each side of the triangle. MP or PN and MN. They are all difficult. They're irrational numbers. But this is unit to square. I said that unit to square. Each side has unit. You have to use this property. You cannot set dp to be 1. It's a unit to square, right? But you can set dp to be 1/3. That's 2/3. That's fine. 2/3, 1/3, 1/3. Here's 1/2, 1/2. Okay. Right. I think this is not the best solution. Okay, the best solution is to use subtraction. Okay, so the area of the triangle M and P. Okay, P and M is the same. It's going to be the area of the square minus the area of the three pictures around that. Okay, so the area of the trapezoid on the top is half of 1/3 plus 1/2 and multiplied by 1. Okay, that is the area of the trapezoid. And minus the area of the triangle lower right. Okay, the base is 2/3. The height is 2/3. Minus the area of the triangle lower left. It's 1/2 and 1/3. Okay, so you get a fraction. Okay, let's figure it out. What this get? This is a 5 or 6. Okay, and this will be 9, 2 over 9. This will be right, 1 over 12. Okay. Here's these two numbers. Let's look at these two numbers. 5, yeah, it's 12, right? 5 plus 1 is a 6. It's 6. Okay, so it's going to be 1/2. 1 minus 1/2 is 1/2. Then I combine them, 18, 9 minus 4. So I think if my computation correct, it's 5 over 8. 18, 5 over 18. Now, if you find each side of a triangle, that will be irrational numbers, and then you're trying to use the Heron's formula. It's too complicated. You involve radicals, you involve regular. You're probably not able to simplify. Okay, so now we get 5 over 18. This is called subtraction method. All right, so the next problem is this is going to be a rectangle. All right, so A, B, C, and D. And here's E. Okay, so we know that the area of the triangle ABE over the area of the quadrilateral, and actually this is a CDAECD. Okay, this is actually the trapezoid. Okay, it's going to be 1 to 11. Find the ratio BE over EC. Right, so please work out. So you know the area, you know the ratio of the area, and can you find out the ratio B over EC? The size of the rectangle is not given. Okay, the size of the rectangle is not given. All right. Now to solve this type of problem, because the size is not uniquely given, so you can make this side to H, and this is X and Y. So what you have to do is just express the triangle, area of triangle in terms of XH, right? So then you're trying to find out the ratio X over Y. Okay, this side of the triangle of ABE is going to be half of H and X, right? The area of the trapezoid will be the trapezoid, right? This is X plus Y. So X plus Y and the plus Y divided by 2 times H. And you will see that first of all, H will be gone. H will be gone. 1/2 is gone. And you get X plus 2Y equals 1 over 11. Okay, so then you can find the X over Y. So 11X equals X plus 2Y. Then 10X equals 2Y, right? And what is the value of X to Y? And BE and EC, BE and the EC is going to be, it's going to be X over Y. And what is X, right? X over Y is 2 over 10, which is 1 over 5. Okay. All right, now our next problem is I have A, B, C, D. Okay, A, B, C, D is a triangle, is a rectangle. A, B, C, D is a rectangle. Okay, so this is a E. Okay, EC equals 5 and AE equals 3. Another important thing is this is the right triangle. Okay, find the area of the rectangle A, B, C, D. All right, so can you do that? So this side is 3 and this side is a 5, okay? Yeah, please work out this. You have to find the area is a rectangle, right? Question is the area of rectangle. What do you need? You're not given the height, you're given the width, you're not given the length. Neither of them. So let's think about, right? This rectangle, you want to find the area. So you have to find out this side A, this side B, right? Okay. This is a B. Now, clearly AC is going to be 4, right? By the Pythagorean theory, simple Pythagorean theory, right? That's given. Let's put a 4 here. We have learned the similarity of triangles. So their triangles similar. There are many triangles similar, okay? So you will see the triangle ADC is similar to the triangle EAC, okay? What are those two triangles, EAC and ADC? Okay, so let's see. EAC that's EAC, right? For EAC, this side is given, AC side is 4, this side is 3. Okay, and then EC is 5. Okay, but the other one, ADC, okay, this side is B, this side is 4. So these two triangles are similar. You can prove that, okay, why it's similar, because the angle, the corresponding side of the angle. So 3b equals 5 of c, right? So b is going to be 4 over 5 times 3, so it's 12 over 5. Okay. So you find the height of the of the triangle or the rectangle, right? So you figured out, yeah. So DC is A actually, right? So then you can also get okay, 5 over 4 is going to be 4 over 8. So that implies A is going to be 16 over 5. So the area is going to be A times B, which is 12 over 5 and 16 over 5. So it's 192, it's 25. Okay, so here we use a similarity triangle to solve the problem. Okay, another tricky problem, maybe some of you already see it before, and this is a rectangle. Okay, this is I'm assuming this is a swimming pool, right? So this is a swimming pool. Then I put a side length. Okay, the perimeter of the inner rectangle is going to be 24 feet. Okay, and the width is 1 foot. 1 foot. Okay. So what is can you find the area of the, I call the sidewalk? Can we determine? So the sidewalk is the different colors, and I use this color, okay? Right, so to find the area sidewalk, right? You have to know, there are a couple ways to do. Some students divide this sidewalk into rectangles, squares, then find the area for each of them, then add them together. Okay, that's the very nature way to do. But then you say, okay, I don't know the length, don't know the width of the inner product. So I'll give you 1 minute to think of it. Okay. Can you determine the area side the wall? If you have answers, let me know. Okay. So what we don't know is the dimension of the swimming pool or whatever called. Okay, a pool. Okay. We only know the partial information about this rectangle. Okay. The perimeter is 24 feet. Okay. So some of you get the answer. Okay, now you can try in different ways. Sometimes you assume that the dimension. You can say in the inner rectangle is a square. Okay, then each side is going to be 6 feet, right? Right. So then you get an answer, right? So what I don't want to do here is I don't want to assume it's a spatial. Okay. So I use subtraction to find the area. Okay. So this inner rectangle is x times y. So we are given x plus y, which is 12 feet, right? Half of the perimeter. Okay. Then if you add the 1 to each side, this side the x plus 2, this side the y plus 2. Okay. So the area is going to be area of the outside rectangle minus x times y. Okay, so let's simplify. Go ahead in x times y and 2y, 2x, and plus 4. Okay, then x cancel out. Then you will see that you get 2 times x plus y plus 4. So 2 x plus y is 12 plus 4, and that's going to be 24 plus 4 is 28. 28 is correct answer. Okay, good. Okay, so the next problem here is this is a rectangle. I know the perimeter is going to be 80 units. Okay, area is going to be 391 square feet units. My question is, how long of the longer side of the rectangle? An idea? Yeah. How long is the longer side? So if this side is x, this side is y, if x is greater than y, what is x? Of course, you can find the y at the same time. The product is going to be the area, right? Yeah, when you get a problem like that, don't just sit there. You name the variable of the yeah for the picture. Right? The length, the width. Then you find the area. Find the area, right? Write down the area. So area is going to x times y, 391. The parameter is double x plus y equals 80. So that implies x plus y equals 40. Okay, so you get x plus y equals 40, x times y equals 391. Find the x and the y. Okay, are you able to find the larger value of x? That's my question. This is an algebraic problem now, right? What is the best way to solve this? Anyone has answer? Crystal? Can you find the x and y from these two equations? Okay, there are a couple ways to solve this equation, and this is algebra, right? The first one is the most stupid way. You let x to be 40 minus x, and plug into second equation, 40 minus x equals 391. Okay, then you multiply this out, 40x minus x squared equals 391. So you move everything to the right-hand side. Okay, then you have to use what? Then you have to use the quadratic formula to find x. There should be two solutions here, negative b plus minus b squared minus 4ac. Okay, so let's use our calculator to figure it out. Okay. Okay, so it's not too bad. After you simplify, it's going to be 36 over 2. It's a 40 plus minus 6 over 2. So two solutions. When it's a 40, that's 23 plus, right? And the 40 minus 6, okay, this will be 34 divided by 2, right? 17. So there'll be two solutions. Actually, once you get the yx, if x equals 23, y is going to be 17. If x equals 17, y is going to be 23. Okay. Yeah, so the larger number is 23. So the answer is 23. Okay, now there's another way to solve the problem. X plus y is 40, x times y is 391. Okay, so you can use this identity. Okay, you can also use this identity. Okay, which one is more useful? Okay. And if equation 2 minus equation 1, and that would be 4x times y. So this is another interesting identity. And then you know that x minus 1 is x plus 1 is 40, right? So 40 squared minus x minus 1 squared equals 4 times 391. So x minus 1 squared equals 40 squared minus 391 multiplied 4. And we already did that, 36. Okay, so x minus y is going to be 6. X plus y, we know that's 40. So then from here, from these two linear equations, and you can get x. Okay, x is 23, y is going to be 17. Okay, so this is a okay. So our next problem is that this is a trapezoid. Right, trapezoid. Now, by definition, what is trapezoid? Trapezoid, you have two lines parallel. Okay, so this is A, B, C, D. Okay. In the following trapezoid, O is the intersection of A and C, and the B and D. So AD to BC equals 3 to 5. And the triangle, I know that ABC is going to be 20. So area of the triangle AOD equals 7. Find the area of COD. Okay, COD. So we're trying to find the area of this. Okay, we are given the area of AOD and the ABC. All right, so A is, we want to find the C, right? The question mark here. Okay, this 7, that's a bit 20. Okay, we are given the information AD and the BC. Okay, so the idea is very simple. Okay, those two triangles, look at the ABC, okay, and look at the triangle ABC and the ADC. Now, these two triangles have the same height and the same, not same length, right? So the area of the triangle ABC over, okay, let's ADC, okay, over the area of the triangle ABC is going to be the ABC is going to be the ratio, okay? So their ratio is 3 to 5 or not? I forgot. Yes, 3 to 5. We know ABC is 20, right? Area, this is a 20. So we don't know is on top, right? The top of ADC is going to be 7 plus the unknown. Okay, can you get it? All right, now, yeah, this is the triangle we're looking for, right? The area. Sorry. Yeah, if that area is called X, okay, then this is 20, that's a 3 over 5. So you get the equation. Yeah. So now you solve for that, right? 7 plus X equals 3 over 5 times 20. And 5 cancel out, it's 12. So X equals 12 minus 7, which is 5. Good job. Yeah, for the equatorial for the trapezoid, right? For the trapezoid, you know, if this side is given, right, to 3, this side is 5, then draw the line here, right? So A, B, C, D. What is not given is the height, okay? But if you know the area of one triangle, you can get area of the other triangle, right? Not because these two triangles similar, because they have the same height, okay? So if this is there, this is the angle alpha, this will be same angle. So if we know the area of the triangle on the top, ABD equals 7 square units, then the ratio, right? Then the area of the triangle BDC over the area of the triangle ABC is going to be half of 5 times h. The height is h. As the half is 3 times h. H is gone, so it's a 5 or 3. So that's why the ratio. So if you know the area for one triangle ABD, right? Hold on. Yeah, BDC and the ABD, right? So ABD is a 7. So that's why the triangle of BDC is going to be 503 times 7. Okay. Okay, similar, right? Right. My next problem is I have a rectangle. I have a sphere there, then have a 1, 2, 3, 4, 5. So this 1, 2, 3, 4, 5, 6 here, 1, 2, 3. I'm drawing the line here. Okay, not properly. What I wanted to find out is the area of this region. Right, find the area of the trapezoid. Right, this is trapezoid. Okay, can you do that? Yeah, this is a 3 by 6 unit squares, right? Find the area of the shaded region. Okay, please work on this. All right, so to solve this problem, you just need to know the side, right, x. Okay, you cannot just look at, oh, x is like a 2.5. No, you have to prove that. Okay. So how do you solve this problem? Use a similarity triangle. Use a similarity triangle, and these two triangles are similar, right? So this side x, here's one, how many, right? 1, 2, 3, 4. Okay. Then the larger one. Here's 3, here's 6. So those two triangles similar. We use the similarity triangle very often, right? So x over 3 is going to be 4 over 6. Okay, x over 3 is going to be 4 over 6. Okay, x is going to be 4 over 6 times 3. It's going to be 2. It's going to be 2, right? So 2. Is that correct? Yeah. Yeah, it's 2. Okay, so once you know this side is 2, exactly, okay, I did not draw clearly, right? So then the area of this is trapezoid, half of 3 plus 2 times 2, right? Yeah. Yeah, so the answer is going to be the 5. 5 is the correct answer. Okay, why the area of the trapezoid is always, yeah. So this side is A, this side B, this is a height. Okay, trapezoid. Okay, why the area of trapezoid is going to be average value of A and B and multiplied by 2, multiplied by H divided by 2. The same idea like for the triangle, you duplicate. Okay, so let's derive this formula. We keep using the trapezoid, right? So this is A, this is the B. Okay, now you get a parallelogram. Okay, and for the parallelogram, the area is going to be the length divided by times height, and right, and this is double of the trapezoid, that's divided by 2. So this side is so the area of this parallelogram is going to be, right, is going to be A plus B times H. Okay, that's why the area of the trapezoid, right, the trapezoid is going to be like that, right? So the area of the trapezoid is going to be half of that. Okay, that's how do we derive the formulas. Those are the formulas. Okay, and then we use that, And here's a simple problem, okay? And this is the B. Yeah, these two lines are parallel, right? So A, B, C, A, B, C, D, E, right? So ED is parallel to BC, right? So if we know, yeah. Okay, if we know AE equals ED equals AD equals 1, okay? So can we, yeah, then equals, yeah. So EB is going to be, yeah, EB is going to be 3, okay? So we want to find the area of the trapezoid. EDCB, okay? So to find that, you just need to find the area as a whole, triangle, okay? Right, then you take a difference. Okay, so those two triangles similar, so the area of the triangle ADE over the area of the triangle ACB, okay? And that is going to be, okay, that's going to be, yeah, that's a tough problem, right? Yeah, that is actually, okay, this is where going to be the next topic. That's going to be the ratio of the squares, you know why? Okay, this side, AE over AB squared. AE is 1. AB is going to be, here's 3, here's 1, so it's 4. So it's actually 1 over 16. You know, why is it square? Okay, that's a good question, right? Okay, so if you can figure out that, then the bottom part, the numerator, you know this, the area of this numerator, it's a square root over 4 times 1 squared. So the area of the larger triangle ACB is going to be 16 times square root over 4. It's a 4 square root 3. Then you subtract the area of the top one, the trapezoid, equilateral triangle. So EDCB is going to be 4 square root 3 minus square root 3 over 4 times 1. And then you get the area of trapezoid. You cannot find the height of trapezoid. You don't need to find the BC. Then nothing is given. Okay, but you can find the BC later on, right? And then you can also, but you have to find the height. If this is height h, then you have to find this one too. Then you can also get the same answer, okay? So 16 minus, that's a 15 square root 3 over 4. So that is the area, but this is not a very unique way to do. You can step by step find a BC, because ED is going to be 1, you know that, and BC is, you find another. Then using that, you have to find the height of the trapezoid, okay? You probably, the height of trapezoid is a 3 times the height of an equilateral triangle, okay? Right, if we can prove that, then you solve the problem, okay? So we stop here as the last problem at the beginning in Henry.